yesterday's class. So we did the kinematics of the circular motion. So let's go ahead and solve two more problems. So we did few problems yesterday, but let's do two more problems to make sure that we have the momentum. Okay, so let me go to the anti-abhyas questions. Let's try number 6 and 8. Let's begin with number 8, please. I'll read through the question and then I'll let you guys think through it. It says the angular velocity of a particle is given by this vector 4i plus j minus 2k about the origin. Okay. If the position vector of the particle is 2i plus 3j minus 3k, then what is its linear velocity? Now, we talked about the relation between omega, v, and r yesterday. So we said the magnitude of the angular speed is equals to the linear speed divided by r. Yes, no? Because after all, we determine how much of an arc length the particle traces along the circumference, and that in turn determines what is the angle it traces in 1 second. Can you see the relation, omega and v? But in the vector form, omega is, do you guys know what the relationship is between omega, v, and r? Ruchika?
V is equals to omega cross r.
V is equals to omega cross r. So let's use that relationship to determine the linear velocity vector. So once again, let me write it down. So your V is equals to omega cross r. We have been given the omega vector and we've been given the position vector r. This r is the position vector. Okay, so let's go ahead and determine the linear velocity. I'll solve it along with you guys, okay?
Sir, I'm getting B option.
B option, okay? Chavi?
Yes, sir.
Is that what you're getting as well?
Yep. Yeah.
Okay, good. Let's go to the next question.
सर एक बार जो हमने कल लास्ट क्वेश्चन किया था वो आप एक बार बता सकते हैं?
Sure, beta. Can you remind me which one was it?
I don't remember the question number. So I think anti-abhyas का second and third था. So I think ये वाला था.
Okay. It says particle moves in the xy plane. The position vector of the particle at any time is given by this vector. The rate of change of theta at time t equals to 2 seconds is how much? Rate of change of theta. Okay, rate of change of theta, that is d theta by dt. Where theta is the angle which its velocity vector makes with the positive x-axis. Okay, the velocity vector makes with the positive x-axis. So let's see. Did we do this question yesterday or no? I don't think we did this question, right? Ruchika, did we do this question better?
Sir, we did it, but we didn't have the time to discuss it.
Discuss it. Okay. So let's go through this. So once again, theta is the angle which the velocity vector makes with the positive x-axis. Okay. So let's first determine the velocity vector. What is the velocity vector? V is equals to dr by dt. V is equals to dr by dt. So if I were to differentiate this position vector, what do I get? I get 2i plus 4t j cap meters per second. Okay. And they are asking us to determine the rate of angle, the rate of change of theta that it makes with the x-axis. For x-axis, what is the vector along the x-axis? We have I cap as the unit vector along the x-axis. So what is the angle between the two? V dot I. So that we can write as magnitude of the velocity. And what is the magnitude of the velocity? V. By the way, magnitude we can write it as simply V without the arrow at the top, or you can also write it like this, right? Mod of the vector. This is equals to square root of the x component square, Vx square plus Vy square. So this is square root of 20, is it? 2 square root 5. You guys can correct me if this is not right. So then V dot I will be magnitude of V times magnitude of the I vector, which is 1, times the cos of angle between them. Correct, no? And in the by the way, why did I say 4 square? No, that's not right. 4t square. No, I shouldn't be writing it like this. So this is 4t square. So I should rather write 16t square. Yes, Peter? Good, no? Okay, and what is V dot I? V dot I in the, if you were to establish the dot product of two vectors given the unit vector notations, then it is ax bx plus ay by plus az bz, right? If the two vectors are a and b, a being ax I cap plus ay j cap plus az k cap, and same thing for the similar thing for the b vector. So this should be equals to 2. Correct, beta? So
Yes, sir.
is 2 by v, which is square root of 4. I'm going to bring 2 outside. So I'm left with 4 plus 4t square.
सर हम t को 2 के लिए मान सकते हैं अभी से.
Okay, so let's understand what are we interested in. We are interested in not the value of theta at that time, but rather how theta is changing with time, right? So if this is let's say the equation for theta, this is time t. We're not really interested in the value here. We're interested in the slope, how it is changing. Okay? So we have to first establish the relation for d theta by dt in terms of time t. Did I answer your question, or is it slightly different?
No, sir, I got it.
You got it. Okay. Let me take another stab at it, because I think sometimes it's not very easy to articulate your doubt, right? So what you're saying is that if we were to put t as 2 seconds in v, right? So what do we get? We will get 16 times 4, 64 plus 4, square root of 68 meter per second, correct?
Yes, sir.
Right. Now, so we know the velocity at that time. You're absolutely right. but that doesn't tell us how the velocity is changing with time. You get the idea? How things are changing with time, that information is not available when you just look at the value of v at that time. At that time, we're interested in how things are changing, how v is changing with time. And why do I say we are interested in how v is changing? Actually, when you write the expression for cos theta, it is 2 by v. So when you differentiate with respect to v, with respect to time t, then you are differentiating v. So you will get dv by dt. So you would want to know that. So that's why we are trying to determine dv by dt. Correct, Beta?
Yes, sir.
Okay. By the way, what is the rate of change of theta here? So if this is, well, I'll not speculate. Let's go ahead and finish this calculation here. So if I were to differentiate both sides with respect to time t, what do I get? Minus sine theta into d theta by dt is equals to 1 upon square root of, let's differentiate that. So what do we get? So it is 1 plus 4t squared to the power minus half. So you subtract the power by minus 1. So you get minus 3 by 2. So we get 1 upon 1 plus 4t squared to the power 3 by 2. And now we differentiate what's inside the bracket and we'll get 8t. We'll get 8t. This is what we're interested in. So let's find out what sine theta is. Now that we have the expression for d theta by dt, now we'll go ahead and put in t equals to 2 seconds everywhere. So for cos theta, if you put in t is equals to 2 seconds, is it 2 seconds or is it 1 second? 2 seconds. So this will be 1 by square root 17. These are odd numbers, but that's okay. Anyway, so what is sine theta? Sine theta is square root of 1 minus cos square theta. So 1 minus 1 by 17. So square root of 16 by square root of 16 by 17. That is 4 by square root of 17. Yes, Peter? So what do we get? So we get minus 4 by square root of 17 into d theta by dt, 8 into 2 divided by 1 plus 16, that is 17 to the power, so square root 17 into 17. I hope you guys would allow me to write it like that. So what do we get? So d theta by dt is equals to minus 4 by 17. Do we have minus 4 by 17? We don't have 4 by 17. Let's just quickly check. Have we gone wrong somewhere? Have we missed out something? So let's quickly take a look at it. So the velocity vector is correct. Yep. So it is 2i. If you differentiate with respect to time t, you'll get 2i plus 4t j cap. Right? This is correct. The magnitude of this is square root of 2 square plus 16t square. Which means that actually this is 2 square root of 1 plus 4t square. I think we missed out this factor of 2 in here. Oh no, perhaps we did not. No. Okay. So here is the 2, no? Anyway, so what is v dot I? We're trying to determine d theta by dt, where theta is the angle the positive vector makes to the positive x-axis. So this is positive x-axis, the vector in that direction, the vector is I cap. So v dot I, that gave us simply 2, right? So we have 2 on that side, and we have v times cos theta. So cos by square, 2 by 2 square root of 1 plus 4t square. We cancelled out 2, and we got the We got the relation here. So what do we have? So anyway, that was the expression there. We differentiated it. Who's going to multiply it by half here, beta? Right? So let me revisit. 1 by square root x, right? Which we can write as x to the power minus half. So when we differentiate, what do? So minus half comes in the front, right? So we completely forgot about minus half here. Minus minus will cancel out. Right? And you will have a factor of 2 at the bottom. So I'm going to carry in this factor 2 everywhere. So we'll have 2 here. So we'll have 2 here. So 2 by 17.
Sir, I had a doubt.
Yes, Peter?
Sir, I did it through a different method.
Yes,
I
Peter?
wanted to confirm if it was right.
Okay.
Sir, I did tan theta is equals to 2t square upon 2t. Sir, so could you just scroll up from this, so the art vector given, we can take out the relationship between, so tan theta will be 2t square upon 2t here. And then so that is basically tan theta is equals to 2t, and so it will be differentiated both sides.
What you're saying is that tan theta is the y coordinate divided by the x coordinate. Yes?
Yes, sir.
But it does say theta is the angle which the velocity vector makes with the positive x-axis, not the position vector. Right, beta?
Yes, sir.
And note that the position vector and the velocity vector, they are not perpendicular to each other.
Yes.
And what is the answer you got, beta? Was it still 2 by 17?
Yes, sir.
That's odd.
Yesterday I did it through this method, but today I found out this new method. I was just checking this method.
Which is actually, let's use your approach at this point, right? It's not a bad one. So you said, this is v vector, right? So you have some v vector. To find out the angle that it makes with the x-axis, what you do is you divide vi by vx. You could have written it here, tan theta is equals to 4t by 2. That is 2t. Correct, Namita? And from here, you can actually differentiate. So your tan theta is secant square theta. So secant square theta d theta by dt is equals to 2. What is secant theta? 1 plus tan square theta, and tan theta at t equals to 2 seconds is 4, right? So that is 4. So secant square theta, let me just do it slightly at the down south. So tan theta we said is 4. So secant square theta is 1 plus tan square theta. So secant square theta at time to 2 seconds will be 1 plus tan square, 1 plus 4 square. 17. So that is 17, then d theta by dt is 2 by 17 radians per second. Absolutely yes, beta. I think that's a clever method rather than this method, which is lengthier, right? Slightly lengthier. Chavi, beta, you got it?
So एक बार फिर से explain कर सकते हो?
Sure, beta, sure. So let me erase this all and let's redo it. So we have the position vector as r is equals to 2t I cap plus 2t square j cap. So from here, we can find the velocity vector, which is the rate of change of the position vector, or we should say displacement by time, dr is the displacement in differential time dt. So if I were to differentiate this expression with time t, we'll get 2I cap plus 4t j cap. This is my expression for the velocity vector. Now, any vector, let's say a vector, we are trying to find out what angle it makes with the x-axis, right? So for that, all we have to do is divide ay with ax. So tan theta is ay by ax. Yes, Chavi? This part is okay, no, beta?
Yes, sir.
So let's find out the angle that the velocity vector makes with the x-axis using the same approach. So tan theta is vy by vx, which is 2t. If I
So this is to find theta, right?
This is to find theta, yes. Right. So now if I were to differentiate it, so you'll get secant square theta, d theta by dt is equals to 2. And what is secant theta at time t equals to 2 seconds? Well, tan theta at t equals to 2 seconds is 4. So secant square theta, which is 1 plus tan square theta, is 1 plus 4 square, or 17, which means d theta by dt is simply 2 by 17 radians per second. Radians per second. Clear? Yes, Peter? I need confirmation to move on.
Yes, sir. Huh.
We just did this one. Let's look at one more problem wherein we have a tangential acceleration as well as the centripetal acceleration. So let me read through it. So we'll read through the statement together and then you guys can go ahead and solve this one. It says a particle is moving in a circle of radius r in such a way that at any instant the tangential retardation of the particle, tangential retardation, and the normal acceleration of the particle are equal. Okay. If its speed at time t equals to 0 is v0, then the time taken to complete the first revolution is how much? Okay. Shall I solve this one or do you guys want to give it a try? Why don't you guys give it a try? And I'm going to solve on my own on the screen. Yes, Peter, how are we progressing?
सर मेरे आंसर में किसी वजह से लॉग आ रहा है.
Okay, we'll just check it out, Peter. Looks like a minus sign has been missed out. Where is it? We need to look at a better method. I'm not. So let's revisit the method itself and see if we can do it better. But first, let me find out the minus sign. Where is it going wrong here? B is equals to dx by dt. There's no problem there. So we have it here. So this is good. This is good. B is decreasing. So the left hand side is positive, right hand side is positive. That's good. So C by R plus 1 by V0. That is also good. V0t.
So in the integral, shouldn't we be getting r minus v naught t?
Shouldn't we have what?
So in the integral, in the last integral that we're doing, shouldn't the denominator be r minus v naught t?
R.
Yes.
You're getting this as in the. Just check this expression. So R 1 by V minus 1 by V0. See,
So you missed out the minus sign when you integrated v square, 1 by v square.
maybe the actually may that minus sign has to be, so the way it goes away is if you look at the deceleration at, minus dv by dt is v square by r, right? No?
Yes.
Yeah, because v is reducing, dv is negative, right hand side is positive, so we have to keep it negative. And that's what we have here, right? So as time is passing, the v is reducing. Otherwise, your v will be going up. Correct, no?
Yes, sir.
Let's just quickly check that hypothesis. We had minus t there. So t equals to 0, v is equals to v0. But yeah, v will be increasing. Yes, 1 by v is, yeah, good. So we have to have this. Then where else is the problem? So 1 by v is equal to t by r plus 1 by v0. So v is v0t plus r by r v0. And the speed is dx by dt, instantaneous speed, instantaneous velocity, dx by dt. So we integrated that. Right? So dx divided by, so we have dt by dx that thing comes down, dx goes on the top on the other side, and that's what you will get, r v0 on v0 ln of v0 t plus r. We are going from 0 to time t, right? 0 to time t, and the distance covered is 2 pi r. So let's just check time taken to complete the first revolution. If it was some other time t, so you will have 2 pi into some other distance. Time is increasing there, so e to the power 2 pi. So what do we have here? So we got r e to the power 2 pi minus 2 pi minus 1. What's going on here? Can you guys spot any issue here? Let me just quickly check with the answer there. It is B, but the expression dr by dt or dx by dt is, this is the expression we were writing, but there they have written dv by dt is v square by r. That is not correct. That is not correct. It's a deceleration, right? So v square by r right hand side is a positive quantity. That's where it is going wrong. So how do we prove that this is actually incorrect? So let's quickly check. The expression that we were writing is, the expression that we got was t is equals to r by v0 e to the power 2 pi minus 1. And if we were talking about here, what we have is this is essentially 2 pi, the distance, divided by r. That's what it is. Or rather, I should say not 2 pi distance, but rather distance x by r. This is the expression we are getting. The expression that is given is r by v0, 1 minus e to the power minus x by r. Don't worry if you are not able to follow why it is e to the power x by r, but that's okay. So what do we have here? So as the x will be increasing, this will become, this is interesting. So if x is infinity, so that becomes 0, so it becomes r by v0, right? For us, if x is increasing, then actually it is blowing up. So this is not stopping. We have an interesting problem here. Let's see, where did we go wrong? I think we are clear. This is where we went wrong. What's going on here? So let me rewrite it. We'll do it side by side. What I wrote was minus dv by dt, because v is actually reducing, so dv is negative. That's why minus sign. This is equals to v squared by r. So if we integrate, we get minus dv by v squared, going from v0 to some v at time t, is equals to dt by r integral from 0 to time t. So this gives us, so dv by v square integral is minus 1 by v, minus 1 by v. So what do we get here? Minus minus cancels out. So 1 by v, limits are v0 to v at time t is equals to time t by r. So we get 1 by v minus 1 by v0 is equals to t by r. Let's see if this makes sense. Right hand side is always positive, and v, if it is smaller than v0, then this quantity is bigger, then yes, it makes sense. So let me write the expression for vt. Vt is equals to 1 by v0 plus t by r. So I can write this as r v0 upon r plus v0 t. That's the expression we have for vt. What is the expression that they have? They have slightly different. So let's see why. Okay, in this expression, what's going on? So we have, as time t is increasing, right? As the time t is increasing, so here our velocity, this is decreasing as time is increasing. Here, this is interesting. So as time is increasing, this quantity will become 0. So v will blow up. So v is actually increasing according to their relation. Just double check me on that one. So here, as per this expression, if t is increasing from 0 to 1 second to 2 seconds and so on and so forth, then the denominator is reducing. If denominator is reducing, then the velocity will increase. Is that right? Chavi, Ruchika, would you guys agree with this assertion? If t is decreasing, then here v is increasing. And we have a problem with that.
Yes, sir.
Correct, no?
Sir, but it's like in the equation that is given, in that if t is increasing, eventually v will become negative also, right?
See, it's interesting. So it's doing this. So as this is, let's say this is t. So it is blowing up, and then it becoming this. That's what it is, no, madam? Graph. This is v.
Yes, sir.
That's a problem. Okay. But the next step, this expression, their expression is making sense because we do expect as the speed is reducing and reducing and reducing, so your centripetal acceleration is also reducing. Oh no, actually what's happening is your acceleration is also reducing. So the time is supposed to blow up. Do you guys get it? This is a wrong expression. Let me explain once again. Their expression in terms of generic expression is t is equals to r by v0, 1 minus e to the power minus x by r. So as per their relation, x is the distance covered, right? Distance covered along the periphery. When x is 2 pi r, this gives us the time period for one revolution. But what they are saying is that as x becomes large and large and large, your time becomes constant. Time approaches r by v0. So this is their graph. Correct, Peter?
Yes.
What our graph, what we got, which was r by v0, e to the power x by r minus 1. So what does that give us? That again at t equals to 0, this is 0, but ours is like this. Question is, why would we be approaching infinity? By the way, what am I plotting here? So this is x, this is time t. That's what I'm plotting. So imagine what's happening is the deceleration is not constant, but rather proportional to the speed. So as the V is reducing, so is the deceleration. So now the rate of reduction in V is further reducing and reducing and reducing and reducing and reducing. Yes. So it will take almost infinite time to die down. Correct? For the velocity. See, if you plot this graph, V versus T graph, this is 1 by T graph, no? As T goes to infinity, this is how your V goes. V at 0 is V0. Correct, Nabita?
Yes, sir.
And what is the distance? Distance is this area. This area also is approaching infinity. This is interesting. So my assertion is they have actually gone wrong in the very first step when they wrote the deceleration, because that's what it said. The particle is decelerating. The tangential retardation of the particle is this much. So if they are undergoing retardation, then dv by dt, dv would be a negative quantity, right? But the right-hand side is positive. So how can you have left-hand side is negative and right-hand side is positive? Because that's not deceleration, na? dv by dt is v square by r. That's an acceleration. Yes, beta?
Yes, sir.
The basic definition, when you write dv by dt is v square by r, right-hand side is positive. That means acceleration is positive. That means v will increase. But they're talking about retardation. Anyway, enough time spent. Let's move on. This has taken much longer than I anticipated. But did you guys get the idea?
Yes, sir.
Okay. Chavi beta, you're on board?
Yes, sir.
Okay. Now let's jump into the projectile. Okay. So projectile, we'll try and go through it quickly. I'll keep telling you the essentials. It is my belief, and you guys can correct me, that Chavi, you have gone through enough projectile questions in your class. Correct, Nabita?
Yes, sir.
So what I'll do is I'll just point out the different types of questions in the projectile motion, and we'll ensure that we have not missed out any, and we might do one question kind of per question type. So let's speed it up. So in the very first one, very simple concept here. So you have a projectile thrown from the ground and it lands back onto the ground, right? So what are the governing equation for the particle which has been thrown at an angle from the ground? So the particle is moving in the horizontal as well as in the vertical direction, in the horizontal as well as in the vertical direction. Now, good thing about this physics is that we can write our equations separately for the two directions. In other words, the acceleration in the y direction does not make any impact, does not impact the motion in the horizontal direction. Whatever is happening in the horizontal direction does not change or impact the equations in the vertical direction. Otherwise, we would be in real trouble. Our world will look quite strange. But in any case, let's write down the key equations. So in the horizontal direction, we have, if this is the u is the initial speed, angle is theta with the ground. So u cos theta. So the distance or the position of the particle, or I should say displacement along the x direction, assuming that it is starting from the origin 0, 0, will be x is equals to u cos theta into time t. In the vertical direction, we have two equations, two independent kinematic equations. So in the vertical direction, once again, the acceleration is g. The initial velocity is u sine theta. So the two equations, one would relate the velocity at certain time t. So what are those equations? So v y is equals to uy, that is the initial velocity in the vertical direction, times minus gt So I can write this as u sine theta minus gt. This is my velocity at any time t in the vertical direction. Now, as far as the displacement in the vertical direction, we have y is equals to initial velocity u sine theta times t minus half gt square. Minus because acceleration is acting downwards. We are assuming that the upward direction is positive, and that's why we have plus u sine theta as our initial velocity. So there are three equations we have: equation 1, equation 2, equation 3. Remember, if you can write these equations and be clear about them, these are three independent equations. You cannot write any more equations than this for this motion, right? So let's figure out what are the different unknowns. So we have time t, we have the x, we have your y, and let's see what else do we have. So we got 3 x, y, and t, assuming that you know the initial velocity and you know the angle theta. Correct, Namita? And then the fourth one is vy. Okay. So x, t, vy, and y. Now let's figure out a couple of things. Let's figure out the range, the maximum height. By the way, before we do that, note that the horizontal velocity, because there is no acceleration in the horizontal direction, the velocity along the horizontal direction does not change. The velocity at any time in the horizontal direction remains u cos theta. That's your horizontal velocity at all times. Okay. So to find out the range, so range means when the particle starts from the origin, comes back to the ground. Starts from the ground, comes back to the ground, which means in the vertical direction, the net displacement is 0. So you now know y is 0. So you have 3 unknowns left and 3 equations. You should be able to figure it out. So your range would be u cos theta into time t, which is now the time of flight. Now, as far as the x, what do we have? Sorry, y is 0. So y is 0 is equals to u sine theta t minus half gt square. So this then gives us the time of flight as 2u sine theta divided by g. So which means the range is 2u square sine theta cosine theta divided by g. Or we can write this as u square sine 2 theta divided by g. If somebody says, when is the range maximum? Range is max for a given u. For a given initial velocity, when is the range maximum? At what theta is the range maximum? Well, the range will be maximum when theta, sine 2 theta is 1. So R max would be u square by g. And that happens when sine 2 theta is 1, or 2 theta is 90 degrees, or theta is equals to 45. Another thing to notice, we'll talk about this in the next question type, but I'm going to mention it here. Range at theta is equals to, in other words, r theta at theta is equals to r at 90 minus theta. That is at the angle 90 minus theta. Why? Because at theta, your range is u square sine 2 theta divided by g. And range at 90 minus theta be u square sine of 180 minus 2 theta. Sine of pi minus alpha is sine alpha. Yes, would you guys agree? So that again gives us u square sine 2 theta by g. So the range is the same. But in other words, if you throw it at 30 degrees, it is the same as range at 60 degrees. Okay. What else? Let's talk about the velocity at any time t, or let's talk about the maximum height first. So maximum height. What will we do for maximum height? We know the particle, when it reaches the maximum height, its vertical component of the velocity becomes 0. So that means Vy at that point is 0. Let's go back to our equations. So we'll engage equation number 2. So if Vy is 0, that means this time is u sine theta by g. That means after the launch, after this much time from the launch, from the time of launch, our vertical component of velocity becomes 0. So if we put that in the equation for y, we will get the maximum height. Maximum height is u sine theta, or u square sine square theta by g minus half g t square. So u square sine square theta by g square. I'm going to cancel this. So we get u square sine square theta by 2g. ये भी clear है? All set? Shavi beta, all okay now?
Yes, sir.
Okay. So essentially, these three equations you keep manipulating, you keep working with these three, and you can pretty much solve any question on the projectile. Always remember that. What else? If somebody wants to find out the velocity vector, right? What angle does the velocity vector makes at the time t? How would we do that? Let's figure that out. So velocity vector at time t, at some time t. Well, at time t, the horizontal component of the velocity remains unchanged, u cos theta. What is Vy? Vy is u sine theta minus gt. So that means your velocity vector is u cos theta I plus u sine theta minus gt j cap. Now, if somebody were to ask you, at what point is the velocity minimum? At what point is the velocity minimum? So let's see, what point is the velocity minimum? The velocity would be minimum when beta? Chavi, Ruchika?
So at the top,
At the top, the Vy becomes 0. So only you have u cos theta I, right? So V minimum is simply u cos theta. If somebody would ask you, when is the kinetic energy minimum? Then we know kinetic energy is minimum when the speed is minimum, right? Speed is minimum at the topmost point. Clear now?
Yes.
Okay. If somebody were to ask you, tell me the angle theta that the velocity vector makes at time t with the ground, or let's call it angle alpha. How would we do that? So, well, remember the vector is the velocity vector is Vx I cap plus Vy j cap. And what is tan alpha? Vy by Vx. If this turns out to be negative, that means the vector alpha angle is below the horizontal line. If alpha is positive, tan alpha is positive, then it's above the horizontal line. Yes, got it? Got it, no beta?
Yes, sir.
Okay. What else? We'll talk about the average velocity. We'll talk about the equation of the trajectory. So equation of the trajectory, let's talk about that beta. Equation of trajectory. How will I find the equation of trajectory? Let's first understand what do we mean by equation of trajectory, because the same concept is going to come in handy in many other places. When somebody talks about the trajectory or the path, well, they're talking about path, right? So how is the x, y, and z coordinates related to each other? Nobody's bothered about time, right? If somebody says, if we have to go from, let's say, Delhi to Bangalore, then what is the trajectory followed by the train, whatever train you take? Let's say you take some Shatabdi that goes from here to Bangalore. Then what is the trajectory taken? They're not interested in time. They're just interested in the path. So they're interested in XY coordinates for the entire journey. right? If x is this, then what is y? If y is this, then what is x? That's what they're interested in. So what we have to do is we have to remove, so we have three equations, we have to remove the time t. And what we will get is the equation of the trajectory. Correct, Namita? So what will we use? We'll use x is equals to u cos theta t, and y is equals to u sine theta t minus half gt squared. So from this equation, t is x by u cos theta. So you can go ahead and substitute that in, and you will get y is equals to x tan theta minus g x squared upon 2 u squared cos squared theta. So this is your equation of trajectory. It's only the equation is in x and y, and the initial or the initial launch angle and the initial velocity. We clear?
Yes, sir.
Okay. Now we will look at some other question types as well, where the projectile has to overcome the cross over obstacles. We'll learn about those. So I have talked about many question types. So let me do this. Let me just jump in. We'll do one question of each, and then we'll talk about the tricks to solve different other problems, right? And we'll talk about the average velocity during flight as well. So let's go back to our. So let's start with this one. Let's start with the latest question in JEE Main 2022. In the meantime, let me take up the question on the YouTube. So what is the question we have here? कोई पढ़ रहा है कि नहीं? ओके, बेटा पढ़ने वाले पढ़ रहे हैं पढ़ने वाले पढ़ रहे हैं और anyway, so I'm not sure who that comment was intended for, but if there are any doubts, please do write them down. I'll try and solve them as soon as I find some time. So we have been given the launch angle, we've been given the horizontal velocity. Sorry, we not the horizontal, we have been given the initial velocity, 20 meters per second, and the launch angle alpha. And they're asking about the after 10 seconds, what will be tan beta? Tangent of the angle.
Should be option.
B option. Beta, you have assumed that they are talking about the angle beta being the angle that the velocity vector makes to the horizontal, right?
Yes, sir.
Beta, what if they meant the position vector making an angle beta? How would you resolve it then? Tan beta will simply be y by x, yes?
Yes, sir.
Okay. So what will it be in that scenario?
So I'm getting the answer as tan alpha minus 25 sec alpha for some
25
reason.
sec alpha. Where are we going off? So let me quickly do this one. So we're talking about this is the angle alpha, this is u at time t equals to 10 seconds. What is the angle beta it makes? So tangent beta is Vy by Vx. What is Vy? Uy minus Gt divided by Ux. What is Uy? U, which is 20 sine of alpha, minus t is 10 seconds, and g is also 10, minus 100 divided by u cos theta, so 20 cos alpha. So
Sir, I took I took y by x instead of vy by x.
okay, so then what you found is what I was checking with Ruchika, that if they were asking for this angle, what is this angle? This is the angle that the position vector makes with the horizontal. Then that's a different question altogether. This question is not very clear here. When it says after 10 seconds, its inclination with the horizontal, is it talking about the particle? Anyway, so that is not a very well worded question, unless there is a typo in the question when it was brought in. But I don't think there is a typo. Yes, beta? Chavi?
Yes, sir.
Okay. So how much time do we have? Let me check. We have perhaps another maybe minute or two. So let's do a few more questions. So they're given that the person can throw a ball up to a maximum range of 100 meters. And they're saying how high above the ground he can throw the same ball. Once again, if you forgot the expression for the range, quickly derive it. The more you, Chavi Bita, the trick is, or many students fall into the trap of thinking, I'm not getting the concept, I'll remember it. I think I said it in the last class as well, no? Right, Bita? So we need to make sure that we don't try and, or maybe not in this class, in the class 12 session. But the problem is there are so many equations with so many finer points. There is no way humanly possible that you can remember them all. Right? There's just no way. So it's very sad when you hear students saying, oh, actually the paper was very simple, but I couldn't remember the formulas. Well, that's a human limitation. So if you don't understand the concept, remembering the formulas is difficult. And why do you want to remember all the formulas? Remember the basic ones, and you should be able to quickly derive the whatever you need for the specific situation right there and then within a matter of few seconds.
Sir, is the answer 50 meters?
How much is it, beta?
Sir, 50 meters. B
50
option.
meters. Okay. So u square by g is given, right? The range is u square sine 2 theta by g. So maximum range is when theta is 45, that is u square by g is given. That is 100 meters. So u is 10 square root 10, if I got it right. Ruchika, is that right, beta?
Yes, sir.
Okay. And then we need to figure out how high above the ground. Well, we'll use v square equals to u square minus 2gh. At the highest point, your velocity becomes 0. So u square equals to 2gh. H is u square by 2g. U square is 1000 divided by 2g. That is 20. That gives you 50 meters. Shall we clear it up?
Yes, sir.
Okay. Now, just as a quick one, in the next few sessions, it's all about doing a lot of practice beta. Right? So what we'll do is our sessions will involve be a lot of practice of different questions in the tomorrow's class. So if there is anything that I can help you guys to prepare for it, please let me know. And I'll talk about these questions, right? Average velocity during a symmetric part of the flight, radius of curvature at certain point along the trajectory. Have you done this one, Beta? Shall
Yes, I have solved a few questions like these.
like these? Okay. ठीक है बेटा. So let's see if we can speed things up. So tomorrow we'll kick up from 25 onwards. Try and do some problems from the NT Abhyas and solve the JEE advanced question from question type number 24 if you guys find time. Let me quickly check. I gave you guys some assignment on chemistry as well as physics. Have you guys done that? Physics you guys have, right?
Yes, sir.
Okay. And chemistry?
So I've done a few, and about 2, 3, or 4 are left.
Okay. Ruchika beta, just stay on for a few minutes. And Chavi beta, I'll see you tomorrow, okay?
Yes, sir. Thank you, sir.
Alrighty beta, take care. Bye-bye. And for the students on the YouTube, we are going to switch over, or we're going to end the sessions. So keep practicing. It's all about practice in physics, right? So don't miss out on the practice. Just knowing the concept will not do any help, right? So make sure you're continuously practicing. Practice every day as much as you can. Physics, chemistry, maths, and have fun while doing it. Alrighty, I'll see you tomorrow.